assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So here for part A, we're going to compare the given equation with equation 15.3. Comparing the given equation with equation 15.3, we see that the angular frequency is 10 radians per second, and we can say that the frequency would then be equal to the angular frequency divided by 2 pi, and so this is equaling 1.6 hertz approximately. This would be our frequency of oscillations for part A. For part B, we know that the maximum speed is equaling the angular velocity multiplied by the amplitude or the maximum displacement. We know the maximum displacement is equaling 10 centimeters. Again, we are comparing to equation 15.3. Therefore, the maximum speed would be equal to 10 radians per second multiplied by 10 centimeters. And we find that the maximum speed is going to be equal to 100 centimeters per second, or we can simply say 1.00 meters per second. This would be our answer for part B. For part C, we see that the essentially the maximum displacement occurs at t equaling 0. For part D, we know that because the maximum acceleration would be equal to omega squared times the maximum displacement, then we can say that here this would be equal to 10 radians per second quantity squared multiplied by 10 centimeters, and this would be equal to 1,000 centimeters per second squared, or we can say that the maximum acceleration would be equaling 10 meters per second squared. This would be our answer for part D. And for part E, we see that the acceleration extremes occurs at the displacement extremes. So we can say that acceleration extremes occur at displacement extremes. So this would essentially be x is equaling plus or minus the amplitude or the maximum displacement, or plus or minus 10 centimeters. This would be our answer for part E. And for part F, we can say that using equation 1512, we find that the angular velocity is giving us the square root of the spring constant divided by m. And so the spring constant is going to be equaling omega squared times m, and this is going to be equaling the mass we know to be 0.10 kilograms multiplied by 10 radians per second quantity squared, and the spring constant is then giving us 10 newtons per meter. We can then use Hooke's law, and Hooke's law gives us the force is equaling negative the spring constant times x, and this is giving us negative 10 newtons per meter multiplied by x. And we can say that this is going to be negative 10x. The units here would be newtons, and x would of course be in meters, or would it be actually, yeah, in meters. So we can say x in meters. This would be our final answer for part F. That is the end of the solution. Thank you for watching.